Welcome to a podcast on stoichiometry, a word that means measurement, and you can tell that because there's a word in here that means measurement, meter. And we're going to take a look at moles, a little more complicated look at moles, but it's not impossible. If you need basic introduction to this, you can go back and look at basic stoichiometry. If you need a little more advanced version of this, you can go to Stoichiometry Part 2. So what is stoichiometry? Well, first of all, you need to understand your mole map cold, or you need to understand your relationship between moles and grams, moles and volume, and moles and particles, molecules, formula units, ions, and atoms. In 1 mole, you look at the periodic table to find the mass in grams of anything, gram, formula, unit, mass. You look in, whenever you're going to liters, you use 22.4 liters. That's the volume of a mole of gas. And you use 6.02 times 10 to the 23rd. If you're hesitant on using this mole map, you need to go back and look at the mole map podcast. And again, there's 2 parts to that as well. Stoichiometry deals with 2 different parts of an equation, a balanced equation. Now, in the basic stoichiometry, or an introduction to stoichiometry, I take you through eggs and cake mix to make yummy cakes, which gives you a basic analogy. I'm going to assume that you either understand this or that you have watched that. And we're going to go ahead and take a balanced equation. My balanced equation in this case is going to be if I take sodium plus chlorine, remember that's diatomic, make sodium chloride. And this is a solid and this is a gas. We're going to make that a solid. That's fine. Now, if you notice, this is not balanced, so I'm going to put a 2 out in front of here and a 2 out in front of there. So now I have a balanced equation. And in this balanced equation, it says that I have, for every 2 moles of sodium, right? For every 2 moles or 2 molecules of sodium, I need 1 molar molecule, right? That one's there, you can write it or not, of chlorine to make 2 moles of sodium chloride. That's my relationship. That's my molar ratio. I'm going to put 1 there just so you can keep track of it if you'd like to. You don't have to write it. So let's say I have a problem. And my problem is that I have 2 moles of sodium. How many moles of chlorine? How many moles of chlorine will I need? Well, what do you know? This is like sodium's land right here. And this is chlorine's land. And there's a relationship. There's a molar relationship for chlorine and a molar relationship for sodium. Just like the mole map that we use back here on this page. Okay? Now, what is the link that you see in front of you between sodium and chlorine? There is a bridge between the 2 of them, a relationship, and that relationship is my balanced equation. My balanced equation links or shows me a relationship between sodium and chlorine. It tells me that for every 2 sodiums, right, you know this, for 2 moles or molecules of sodium, I need 1 mole or molecule of chlorine. That's my relationship between the 2 of them. Now this has a fancy name, because of course it does. It's called a molar ratio. Now what do I know? I know that I have 2 moles of sodium. So I'm going to go ahead and underline my 2 moles and circle my I don't know moles of chlorine. And I'm going to start with 2 moles of sodium, because that's what I know. That's what I'm given. I'm going to draw my train tracks. What do you know you do not need? You do not need moles of sodium. You don't want them. You want to somehow to change this to moles of chlorine. And you can do so because of your molar ratio. Your molar ratio tells you that you have 2 moles of sodium for every 1 mole of chlorine. So what happens with our words here? Our words cancel. Moles of sodium cancel. I'm left with moles of chlorine, and I do my math. 2 times 1 on the top divided by 2. So my answer is 1 mole of chlorine. Don't you always need half as much? For every 2 moles of sodium, you need 1 mole of chlorine. So every 2 moles of sodium, you need 1 mole of chlorine. We're going to go ahead and just keep using this equation, if that's okay. All right? So I actually should write it in, but we'll go ahead and do 2Na plus 1Cl2 makes 2NaCl. So let's go ahead and try this. Let's say I have 3 moles of sodium equals how many moles of sodium chloride? And yes, I know you can eyeball this. You can tell me that if there's a 2 to 2 relationship, that if you have 3 moles of sodium, you should also have 3 moles of sodium chloride. But I need you to understand it this way. I need to understand in a relationship that's a molar ratio. What's the molar ratio? Well, if I wrote the molar ratio out here, 2 moles of sodium is the same as 2 moles of NaCl. Right? Now, where's our mole? And the reason I'm doing this, you'll see in a second. There's my mole map here and my mole map here. What is this for? This is for NaCl, and this is for Na. Because this is what I'm given. Aren't I given this? Right? I know I have moles of sodium, so I'm going to write 3 moles of sodium. That's what I'm given. I underline it. I start with it. What do I need to find? What am I looking for? I'm looking for this. I'll use the green, I guess. I don't know this. This is my unknown. Correct? This is my question mark. So, that's what I want to find out. That's what my answer is going to be labeled in moles of NaCl. So, what are we going to do? We're going to go ahead and change this. We are physically going to move from moles of sodium and use our balanced equation bridge, or bridge between what I know, what I'm given, and what I don't know, NaCl. What do I know about these? I know that for every 2 moles of sodium, I make 2 moles of NaCl. So I'm going to use this information right here. I'm going to physically change moles of sodium, words on the top up here, go down here. Right, I'm leaving moles of sodium and moving from the mole hole on sodium all the way over here to moles of NaCl. So write moles of NaCl here. And where do the numbers come from? My balanced equation. So for every 2 moles of sodium, I need to make 2 moles of sodium chloride. That's what my recipe tells me, right? 2 makes 2. Now when I do my math, 3 times 2 is 6. Divided by 2 is 3, which we knew would be the same because for every 2 of these you make 2. It's a 1-to-1 relationship. All right. Make a big eraser here. Oh, that didn't work. Let me just go ahead and clear everything. It's easier. All right. So let's try a step harder. Let's try. I have. It's a crazy marker. There's your balanced equation. And what do you know is true? Let's say I know that I have 3 grams. Actually, let's use 63 grams. 63 grams of sodium chloride. Okay, that's what I know I have. So let's turn this into more of a word problem. I have 63 grams of sodium chloride in a beaker. How many liters of chlorine did I use? So what do you know? You can go ahead and say, I'm going to start with NaCl. This is where NaCl lives. That's what I'm given. So what do you know? You know you have 63 grams of sodium chloride. So you're going to start your equation like this. That's what I know. Now where are you going? You're going to chlorine. And what about chlorine? Right? And you're going to liters of chlorine. So this is a little harder than the last problem because you're actually going to go ahead and use a mole map on this side. Now what's our mole map? Grams is here, right? Actually, let me use red, okay? That way you can see it a little better. So I've got grams over here. I've got liters up top, and I have particles down here, like molecules, etc. Same thing on this side. Liters, grams, particles, like molecules over here. So now, you know this is a stoichiometry problem. You know you're going to use this mole map, right? Here's my mole map over here. Balanced equation, right? That's your bridge between what you have and what you need. Mole map. Here's your mole map. See, balanced equation, or excuse me, mole map, balanced equation, mole map. So let's go ahead and do this problem so you can see the 3 steps. I'm going to go ahead and erase this because you know what? I don't need liters. I don't need molecules on this side. Why? Where am I starting? I'm starting on grams. 63 grams of sodium chloride, aren't I? Aren't I right here? Okay. So I'm going from 63 grams of sodium chloride. What do I have to do? I have to, highlighter here, I have to change grams to moles of sodium chloride. That's my first step. Then I need to cross my bridge. I meant to change colors, sorry. I need to cross my bridge and use my molar ratio. That's my second step. And my third step is to go up here to liters. So I have 3 steps. Let's go ahead and do them. Whoopsie. All right. That's like a pink. Sorry about that. Still pink. Oh, because it's a highlighter. Better. All right, now. What do I know? I know I have 63 grams of sodium chloride, right? That's established. I need to find liters of chlorine. That's what I want to know. That's where I need to end up. So my first step here is to change grams of sodium chloride into moles of sodium chloride. That's this step right here, this blue area. I'm changing grams to moles. I look at the periodic table, and there's 1 big mole in this mole hole. So I put 1 mole here. And when I add up sodium chloride, sodium is 22.99 on my periodic table. Okay, you look on your periodic table too. And chlorine is 35.45. So when you add those up, you get 58.44. Right, that's sodium of the periodic table, and that's chlorine of the periodic table. Now I'm not done, but where am I? I'm physically on this mole hole for sodium chloride, and if I stopped and did my math, I would get rid of grams of sodium chloride and have moles of sodium chloride. Is that what I want? Nope. I need to keep going. So now what I need to do, now I'm at the point where I can change moles of sodium chloride into moles of chlorine. I'm going to use my bridge, my balanced equation bridge. So, words up top go where? If you sit on the bottom, you're correct. So I'm going to take moles of sodium chloride. I'm going to physically change them to moles of chlorine. Look at this. Isn't this your path right here? Right, we established that to go on this path, this is what I'm doing. This is what I'm doing right here, right? This green matches this green here. I'm changing moles of what I have to moles of what I need. And to do that, I'm going to go ahead and call this my balanced equation bridge. So what's my balanced equation? Well, if you look, go and use this right here. I've got 2 sodiums for every 1 chlorine, don't I? Oh, I'm not even looking that. What am I doing? I've got 2 sodium chlorides, for every 1 chlorine. So what are my coefficients? Well, you look at what's in front of NaCl, and what do you have? You have, sorry, the custodian walked in and distracted me for a second. So what do? You have 2 moles of sodium chloride out of my balanced equation for every 1 mole of chlorine. Isn't that true? Right, for my balanced equation? That's my molar ratio. Am I done? Well, what do we have? Moles of sodium chloride cancel. And what have I done? I physically changed moles of sodium chloride physically to chlorine. Right? Aren't I here now? Now if I physically stopped, what would I have? Moles of chlorine. Is that what you want? Nope. So you need to keep going. And you need to go so that you change moles of chlorine to liters of chlorine. Can you do that? Can you change moles of chlorine to liters of chlorine? Sure you can. And what do you pass by? 22.4 liters. So if you look what's true, I'm putting 1 mole, right? Because I'm in that mole hole, and there's 1 mole of chlorine. And what do you pass by? 22.4 liters. Aren't I doing this step? Right here, right? Up. And what was this step right here? This step was here. See my steps? So this is number 1. Right, this is 1 right here. Changing grams of what I have to moles of what I have. This is my second part, using my balanced equation bridge. Changing moles of what I have to moles of what I need, chlorine. And what's my third step? Look what happens. My moles of chlorine cancel, and I'm left changing moles to liters. I write my equal sign, and how do you do your math? However you do it, I'm going to go ahead and take 63 divided by 58.44 times 1, you don't need to do that, divided by 2 times 22.4. And I get 12.07. And I'm label that liters of chlorine, because that's what I ended up at. I ended up starting at grams, crossing my bridge, going through my mole hole, going to balanced equation, and up to liters. Let's try another one. Let's use a different balanced equation. Let's use hydrogen gas plus oxygen makes water. Now, by the way, if you notice in these stoichiometry problems, I always have 2 things. I have 32 liters of hydrogen equals how many grams of oxygen. What do you notice? You have 2 separate entities. You're starting with 1. So what are you starting with here? Hydrogen is what you know, and oxygen is what you want to find, don't you? Okay. So what do? You underline what you know. So you write 32 liters of hydrogen. And over here you come and you say how many grams of oxygen. So, what do you know? Well, if you're on liters, aren't you starting here? Wow, that's kind of wide. Let me get that wide. All right, we'll try and do that. There you go, a little better. So I'm starting on liters, and I'm going to go down to moles. So my first step is to change liters to moles. So let's do that. I do not want liters of hydrogen. I do want moles of hydrogen. I'm in a mole hole, and there's one big old mole here. That's right, 1 mole here. What's the number you pass by? 22.4. All right. Now, if you physically did your math, where would you end up right now? You would end up being, with liters canceling, you'd end up with moles of hydrogen. Is that what you want? Nope. You want grams of oxygen. Grams of stuff on this side, right? So you are going to physically have to leave hydrogen and go to oxygen. What's your bridge between them? What do you know? Well, you know that you can use a balanced equation as a bridge to go between hydrogen. Now, what do you know about hydrogen? In your balanced equation, for 2 moles of hydrogen, you always need 1 mole of oxygen to react with it. So in this step, you do not want moles of hydrogen. See that you're leaving this mole hole. You're leaving it. You're going over to, I'm going to write this over here. It's a little darker. I'm going to oxygen's mole hole. And what about the moles? What's the relationship between them? In my balanced equation, I have 2 moles of hydrogen and 1 mole of oxygen. That's my molar ratio. What would happen if you did your math here and stopped? You would change moles of hydrogen into moles of oxygen. Is that what you want? Nope. You want grams. So you are not done yet. But you're closer. You're on oxygen, and so now you can go ahead and figure out the relationship between oxygen, moles of oxygen, and grams. So, words up top, come down here. You do not want moles of oxygen. You want grams of oxygen. And to do that, you look at the periodic table. If you remember, there's 1 mole in oxygen's mole hole. So 1 goes here. And I look on the periodic table, and 1 oxygen is 16, but it's O2. So 16 times 2 is 32 grams in O2. Now to do my math, what do? 32 divided by 22.4 divided by 2 times 32, or however you do it. But however you do it, you should come up with 22.85. You're talking about significant figures, you're talking about 23 grams of oxygen. Right, this is grams of oxygen also. Now I have a question for you. I have 1 mole here of hydrogen. Does that mean I have 1 mole in my balanced equation, or 1 mole here? 1 mole here. Because what am I doing in this step? In this step, I'm changing liters to moles. And there's always 1 mole equals 22.4 liters. What about this step? What am I doing in that step? I'm changing moles of what I have to moles of what I need. And I get that information up here. So there's a 1 in front of this oxygen right here because there's a 1 in my balanced equation, not because I'm on a mole map. The relationship is 2 hydrogens for every 1 oxygen. Now, why is there a 1 here? Because I've got 1 mole changing to grams. So the 1 in front of this oxygen is from my balanced equation. The 1 here is from my mole map. So whether you use my train tracks, my bridge, whatever, you have to remember that whatever you have, you need to change whatever you have to moles. So let's go ahead and use that. 2 moles, 2 moles of hydrogen, or molecules, plus 1 mole of oxygen, right, makes 2 moles of water. So let's say I have 3 moles of hydrogen equals, I have no idea how many liters of water. Let's do this equation. So, if you don't want to use my bridge and you just want to use steps, the first step is change to moles of your given. The second step is use the molar ratio. The third step is to change back to whatever you need. Change need, right, to what you want to find. So how do you do that? Well, do we have moles? What do we know? We know we have 3 moles of hydrogen. That means, guess what? I already have moles. So write down what I know. 3 moles of hydrogen. What's my next step? Well, I need to go, and this is hydrogen, I need to go visit water. How am I going to get there? If you said to draw a bridge, or forget the bridge, use your balanced equation, your molar ratio, I'm going to take moles of what I have, H2, and change it to moles of what I need, H2O, right? I'm going this direction. My balanced equation, for every 2 moles of hydrogen, I have 2 moles of water. And if you tell me that's a silly step, that's fine. But if you leave it out, it's wrong. And if you leave it out and it's not 2 to 2 or 1 to 1, then you're wrong and you're going to get it wrong and you don't want to do that. Because people use this. They use this to cook food and sell it. They use it to take medications and give medications to other people. So if you calculate it wrong, you could get very sick or not be cured or die. And that's not a good thing. So, or you can make bad food to sell and then you end up having some kind of weird reaction and it goes bad and you lose a lot of money and get people sick. So, what do I do here? Am I done? How do you know? Well, what have we physically done in this step? I've taken 3 moles of hydrogen and got rid of my moles of hydrogen, right? So what am I on with words? I'm on moles of water. That means physically, guys, I'm right here. Is that where you want to be? No. You want to be on liters. That's what you have to do. You have to go up to liters using your molar relationship on your mole map. So I do not want moles of water. I do want liters of water. And when you know, in 1 mole of water, there's always 22.4 liters. So on your calculator, what do? 3. Now you can do times 2 and divide it by 2 if you want to, but they cancel out, so you'll get the same thing. And then times 22.4. And that gives you 67.2 liters of water. Let's try some more. So let's say I have, go back to this equation. Okay, we'll do a simple one. So 1 mole, actually just make it 4 moles of sodium equals how many moles of NaCl? That's our first problem. Our second problem is going to be 3 moles of chlorine equals how many moles of sodium? Now where are you on this kind of problem on your map? If you want to look at a map, you can look at a map. I have moles of sodium, going to moles of sodium chloride. What do I need to change what I've been given to what I want to find out? If you said a bridge, a balanced relationship, and a balanced equation, you're correct. If you're using my steps, then the first step is to find moles of what you have, what you're given. You have moles of what you're given. So I write down what I know. I do not want moles of sodium. I do want moles of what? What am I trying to find here? Moles of sodium chloride. What's my bridge? What's my relationship between them? Moles. Next step is balanced equation. So look up here. 2 moles of sodium, 2 moles of sodium chloride. Do I stop? Yes, I do, because I'm already here. My words tell me I'm there because moles of sodium cancel. I'm left with moles of sodium chloride right here. So 4 times 2 divided by 2 is 4 moles of sodium chloride. These are called mole-mole problems because you're going from moles of one thing to moles of another. Let's try number 2. What do you know in number 2? Do you have moles? Yes, you do. So how many moles do you have? 3 moles of chlorine. I'm writing that in first, aren't I? What I'm given is chlorine. What do I want to find out? Moles of sodium. So this is where chlorine lives, and this is where sodium lives. What's your relationship between two different things? Your balanced equation, your bridge. I do not want moles of chlorine. I do want moles of sodium. In my balanced equation, what do I know now? I know that for every 2 sodiums, I need 1 chlorine. 3 times 2 is 6, divided by 1 is still 6 moles of sodium. Do you have moles of what you have, what you're given? Yes. Did you use your balanced equation as a bridge, as a relationship, as a molar ratio between them? Yes. And why did we stop at moles? Because that's what we need to find. Let's try another one. Let's try going from grams to grams. They call this a mass-mass problem because you're starting at mass of one thing and ending up at mass of another. So let's start with 3 moles. Excuse me, I said grams, didn't I? 3 grams of sodium equals how many grams? Make this 23. How many grams of chlorine? Now, what are you given? This is what you're given. This is what you need to find. If you're using my map, you're on grams and you need to change it to moles. If you're not using my map and using my steps, you ask yourself, do I have moles of what I'm given? The answer is no. So how do you change 23 grams of sodium into moles of sodium? You look at your periodic table. The word grams of sodium goes down here. You change it to moles of sodium because in 1 mole of anything on the periodic table, you look, right? And this is 1 mole in my mole hole. This is 22.99 grams on the periodic table. Now if I actually stopped and did my math, don't. But if you did, you'd be changing grams of sodium to moles of sodium. Step 1. Step 2, if you look at my map, then you go ahead and doing what? You're using balanced equation bridge to use your molar ratio, right? This is your balanced equation. Step 2. If you're not using the map, you're just going, okay, I already have moles, and now I'm going to go ahead and use my molar ratio that's in my balanced equation. I do not want moles of sodium. I do want moles of chlorine, because I'm going from little sodium's land to chlorine's land. Now what do you know in your balanced equation? That for every 2 moles of sodium, right, you need 1 mole of chlorine to react. It's always the ratio, the recipe, the balanced equation, the molar ratio. Okay, and what do I need to do now? Am I done? Oh no, look, it doesn't say moles. Now it says mass of chlorine. So I need to continue, and my third step would be to change my moles back to grams using the periodic table. So I do not want moles of chlorine. I do want grams of chlorine. On the periodic table under chlorine, it's 35.45 grams for chlorine. And if you multiply that by 2, because there's 2 chlorines, right? Cl2, that's 70.9 grams, because it's Cl2. Now, what do we physically do in this step? Oh, in this step back here, what do? We changed moles of what we had to moles that we need, right? We changed what we had to what we need. What do we do in this step? We changed moles of what we have, and there's 1 mole here, to mass using the periodic table. So what are you going to do? 23 divided by 22.99, which is almost 1, isn't it? 1.000 something, divided by 2 times 70.9. And that should give me 35.46. So if you round this using significant figures, it's 35, and we are labeling it grams of chlorine. Getting easier? Let's try another one. Let's try going from 28.5 liters of chlorine equals how many formula units? There's a new one. Of sodium chloride. And if you remember, sodium chloride is an ionic compound, and so we're calling it formula units. Here's my balanced equation. Remember, they have to give you one, or you have to be able to write one and then balance it. So what do you know? First of all, you ask yourself a question. Do you have moles of what you're starting with? Nope. So I'm going to go ahead and write 28.5 liters of chlorine. If you're using my map, you're up here. And you're going from liters to moles. How many liters are in 1 mole of chlorine? 22.4. Right? That's why you have to know this mole map cold. And this is chlorine. This is chlorine's little land, the relationship. The little land over here is sodium chloride, and that's what you want to do. You want to change liters of chlorine into formula units of sodium chloride. So, can I magically change it, or do I need a relationship? You have moles of what you have, right? Moles of chlorine would be what you solve right here. So I'm going to go ahead and do what? I'm going to use my molar ratio. Oh, and there's the bell. My molar ratio between chlorine and sodium chloride. And in my balanced equation, for every 1 mole of chlorine, I make 2 moles of sodium chloride. 1 mole of chlorine, right? Chlorine moles go down here. Moles of sodium chloride go up top. And my numbers come from my balanced equation. Where am I physically right now? I'm right here. Is that what I want? Or do I want formula units of sodium chloride? Formula units, don't I? Okay, I'm going to get a scientific calculator here. Put you down. Sorry. Okay, what's the next step? The next step is to go down. Right here. And that's not a good color, is it? So, I'll use red. Use red. There you go. Here I pass by 6.02 times 10 to the 23rd. And that takes me down to formula units. So, in 1 mole of sodium chloride, right, we're on a mole map, we go to 6.02 times 10 to the 23rd formula units. So doing your math, what do? 28.5 divided by 22.4, right? And what happens? Liters cancel. That will leave you with moles, but you're not done yet. Then you multiply it by times 2, and what happens this step? Moles of chlorine change to moles of sodium chloride. And then you're going to multiply by 6.02 times 10 to the 23rd. And you get, right, and moles of sodium chloride, cancel. And you get the answer as 1.53. Now be careful. Look over on your calculator. It says E. That E to the 24th means times 10 to the 24th formula units of sodium chloride. Okay? So I'll do some more problems later, but this is a good start for you to look at for your quiz.